The final section of the homework are the word problems. These are about the same difficulty as the one on the test. This one has a similar cousin. Same with this one. So Jennifer's rectangular flower garden has a length 5 less than twice the width. A 4-foot brick border is going to be added around the garden to give us a total area of the garden and border 255 feet. So ultimately, this entire garden and border has an area of 255 square feet. We need to figure out the length and width of that garden. Well, the only thing that I know that relates area and length and width is the formula. Area equals length times width. In order to solve any equation in math, you need to have as many equations as you do letters. Or you need to be able to get rid of some of the letters in replace of numbers or in terms of itself. That way we don't have to deal with all the different ones. We can get rid of A by making it 255. What we now need to do is get rid of one of these letters. That way we're only talking about W's or just talking about L's. So that's where all this information comes in, especially this right here. So I'm going to draw the garden again. And we find out that the length, L, is equal to twice the width minus 5. Sweet! But unfortunately, if I were to multiply this times that, I would only get this area. And I have no idea how large her flower garden is. The area that we were given, the 255, is this garden plus the 4-foot border that she added around it. So what we really need is the distance from this bottom left corner to the bottom right corner. This entire distance of garden and border. Well, we know the pink line is 2W minus 5. We know that this green line is 4. This green line is 4. So adding all this together, we get 2W plus 4 minus 5. The length is 2W plus 3. Negative 5 plus 8 is 3. The width we need from here to here is the W, the original, plus the 8 feet in border. So we end up with 2W plus 3 and W plus 8. What we have done is made this equation up here that has 3 letters become an equation with just 1 letter. This is solvable. We do have to multiply these two binomials. We get 2W squared plus 16W plus 3W plus 24. So 2W squared plus 19W plus 24 is equal to 255. There's our quadratic. We're going to get it to equal 0. I'm going to jump over here because I'm running out of space. So 0 is equal to 2W squared plus 19W minus whatever the heck that is. So it's 255 and the minus 24. We get negative 231. I'm going to need two numbers. then multiply to 462, that combine to give me 19. So I'm going to just kind of check, starting with 1, divide by 2, divide by 3. I'm going to jump ahead, divide by 8, nope. Divide by 9, maybe 12, nope. 13, 14, and that's it. 14 and 33, I need it to be a negative 14. So 2w squared minus 14w plus 33w minus 231. Factor by grouping. I can take a 2w. So I'm guessing, because I need that to become a w, I'm going to take out a 33. I'm going to double check to make sure this is even possible. 231 divided by 33. Oh, it's 7. That's what we need. So we get 2w plus 33. W minus 7 equals 0. Finally, we can use our zero product property. So the width of our garden is either 7 or negative 33 halves. Well, you can't have a negative distance, so we're going to toss that one out. So we know the width is 7. We can now go backwards to our problem. Plug in the 7 right there. 2 times 7 is 14. 14 minus 5 gives us 9. Is that right? 7, 14 minus 5 is 9. Okay, just want to double check. There's the width of her garden. 9 by 7. Then the next word problem is a physics one. So we've got our equation right there. So Jack throws a pop-up ball for his kid to catch, so he's over here. He throws the ball. Apparently Jack is giant. He's probably like a 6-foot person, because when he throws it, it's going to leave his arm 9 feet above the ground, which isn't all that crazy. I mean, if you're a 6-foot tall person, your arm is about 3 feet. When he's all the way at the very top of his throw, 6 feet height plus 3-foot arm gives you 9 feet above his head. He throws it at 8 feet per second, so it's actually a pretty slow toss in the air. It's not my greatest parabola, but that's okay. And our kid is going to catch it 1 foot above the ground. So it's not going to hit the ground. They're going to make a diving catch. It's going to look amazing. Catches it 1 foot above the ground. We're being asked to find how long, which means we don't know time. So we must have been given the height. We did. He caught it 1 foot above the ground. It was amazing. It's the greatest catch we've ever seen. So we take our equation. Instead of h, we replace it with 1. We get it equals 0. That's a terrible T right in the middle. Okay, we need to factor this, but I hate when my first term is negative. So I'm going to divide everybody by a negative, and then I see that 8 goes into all of them, so I'm going to divide everybody by an 8 to make our numbers even easier. 0 divided by negative 8 is 0. Negative 16 and negative 8 gives us a positive 2t squared. 8 and negative 8 is negative t. Negative 8 is negative 1. So 2 times negative 1 is negative 2. We need two numbers. Then multiply to negative 2 that combine to give us negative 1. It is negative 2 and 1. I'm running out of room, so I'm going to jump over here. 2t squared minus 2t plus 1t minus 1. Factor by grouping. Two t plus 1 and t minus 1. So the times that the ball is 1 foot above the ground is negative half a second and positive 1 second. So we're going to toss out the negative answer. So when we toss this pop-up, it only took 1 full second from the time that we threw the ball to when our kid caught it. So I must have been playing with my little infant son, and I just lobbed it to him. And it makes sense. He can barely stand, so it probably was a diving catch. Where the negative half-second answer comes from, why it's even considered in the math, is when we go the opposite direction in time. So instead of going this way and being at 1 foot, what happens if we go backwards in time to when we're 1 foot above the ground? Right there. If it took 1 second to get here, going this way took half a second. But that's going backwards in time, which doesn't exist yet. Maybe one day we'll have time travel. So that is a couple of our word problems. Look out for another post of some problems that I would consider putting on your note cards. That could be helpful for tomorrow or Thursday.